look into doing the command line job submission stuff now. And the slides are here in CLI job submission at HTML and there's a PDF form. Doing these things from the command line, again, it mirrors pretty closely what you're doing in the website. And some of this stuff is a little more tedious for doing one at the command line. But if you're doing many at the command line, it's a little more straightforward. So the overview is to first find out where your data is that you're going to be submitting. For things like read files or config files that they're operating out of the workspace, that data has to be uploaded to the workspace. That can be done either manually or the submission scripts will do some automated uploads for you. Need to choose your parameters for this job submission, run the submission, monitor the status, and then view or download your output. The basic workflow for doing these analyses. In the same way that the forms need you to specify the data, these submission scripts do as well. We're going to talk a little bit about data in the workspace in more detail so that we can understand what's going on. The workspace data is defined by a path, which is this format that you'll see in one of two ways, either / then your username at BV-BRC for people who have gotten BV-BRC accounts in, I don't know, the last 6 months or so, / workspace, which is the name of the workspace that the data is in, followed by one or more folders, and then finally the file. For the older accounts, you'll see username at patrickbrc.org. If you've been paying attention, you'll see, that's what Rebecca's paths look like. That's what my paths look like because we have the older accounts. So for instance, the default workspace folder for me is /Olson at patrickbrc.org /home. And again, if you go into the website, these are all of my workspaces. If I click on home and I go over here on the thing on the right side of the green bar, this is that path. So if you have trouble figuring out a workspace path for something where you can browse to it in the interface, you can always go to the folder. So let's go find my test folder. Say I'm looking for, this guy here. If I browse to some arbitrary space, I click on it, I go over here, I've got a path, select it, copy it, and then head over into my terminal window and I can copy my path in there. So that's sort of the shortcut way to get the paths for things that you've browsed to. Right, the question was that I didn't have a path showing up on the right-hand side. If you haven't picked anything on the column on the left, you'll get the nothing selected message over here. Once you click on a thing, then we get the information about the data item. So you would like to be able to browse the data in the workspace from the command line. And there's a program called P3LS that offers this capability. So what this does is list the contents of the folder in the workspace. So I'm going to go back over here to my workspace. I'm going to go, let's say I wanted to see what the contents of my test folder are. Click on this on the left-hand side. Over here on the right-hand side, I can see I've got my path. I'm going to copy and paste this. Copy and paste is a little bit fiddly here. It's really easy to get the part of the colon in the path name where it says path. It's sort of hard to grab this. And I think we should have a copy path button on here to make that easy. So I've copied my path. I'm going to come over here. And remembering our command was P3-ls. And like everything else, if you say P3ls-help, you'll get a nice help message for it. There's not too many options we need to use. I'm going to do P3ls, my path. I can see that, I've got a bunch of stuff in here, right? But this is listed out the contents of this folder. So if you want to get more information about the contents of the folders, you can add the -L option to see a long listing. So we'll copy this over here. I'll use my home folder as the example. Remember, you can't just copy and paste this because it'll tell you don't have access to my home folder because it's not publicly readable. This is exactly what will happen if you try and list the folder that you don't have access to. So I'm going to switch it back to my other non-demo account. So I can see I've got a whole bunch of stuff in my home folder as well. In a sec, we'll go over what these columns are. There's a bunch of information included in here that you may or may not be interested in, but it's good to understand a little bit. There's these letters at the front, these 5 characters here that have meaning. The first one, for something that's also a folder, this is going to be D for directory. That means that the 0 test item in here is another directory or folder. I'll use directory and folder interchangeably. I try to talk about workspace folders because on the web view of things, that's how we talk about them. A capital S here means that this is a larger file that's stored in the backend store called Shock. It's a large object store system. The distinction really doesn't matter to you at this point, but that's where that comes from. We've got the owner of the file or folder, the size of it. Directories, folders show up as 0 size. We've got the date it was created and the file name. Remember that all the objects in the workspace are typed, and there are things that have different actions based on the type. If you add the -- type flag to this, that will dump out the type of the objects in the workspace. So I'm going to take my home folder example and going to say -L -type. So now we see that these guys are folders. This is a config file. This is a read file. We've got some unspecified data types here. So this just gives you another way of looking at your data. These types are the same. I'll again show the parallel to the website, that if I'm looking at, go to the same place in this listing. Let's take this thing called x11p.fq that says it's reads here. This is that same file over here. Over here, it has type reads, and I can change the type here. The type is used here mostly in the website to help limit the files that show up in the dropdown. So if I'm starting up an assembly job, it will limit the files in the dropdown to items of type reads. The file extension doesn't necessarily match it because, for instance, we have both FQ and FQ.gz that are both of type reads here. But FA can be reads or contigs. You can upload your picture of the sequencer and give it type reads and try to send it to the assembly, and the assembler will say, I don't know, that's not really a reads file, but they're meant to sort of ease the process of using the website from the user's point of view.
We got one question here. How do you deal with spaces in a file name?
The command line interface uses spaces to delineate the distinct parameters to the command. Here, say I've got a path name that has a space in it. There we go. Here I've got a folder called Workshop Discovery with a space in it. So if I try to get a listing of that folder, and if I get rid of the long options here, so if I say I've got also patrickbrc.org/home/workshop discovery, what happens is that I get some stuff here, and then I get this error that says path discovery does not include a top level directory. What does that mean? Well, what this means is that the ls command thinks it was 3 different parameters onto it. One, which was home workshop, which happens to also be a valid folder. And then it got a dash, and then it got discovery. That's not what I meant. I meant to give it a single parameter that has that path that has a space in it. And the way we handle that is to put double quotes around the entire path that we want to have as a single parameter. Now we get what we're looking for, the contents of this folder. And again, if we go back to the web interface here, when you copy the path out of here, right now it's got spaces in it, and you'd have to go back and put quotes around it. And again, if you've not used the command line before, we talked about doing up and down arrows to go through the history. You can use the left and right arrows to move the cursor within the command. So I could go through and add the quotes around it like that. That's also a source of mysterious bugs showing up and mysterious errors. And, so if you get something that just isn't working right, that's a thing to go back and pay attention to if you've got spaces in any of the path names. If you want to take a quick look at the file data, there's a command called p3less. Less is one of the commands on Linux that's used to look at things. There's not a less on Windows. It's called more on Windows, but the command is still called p3less here. So say I want to look at that file without downloading it. I'm just sort of curious what's in there. I want to look at xx.fastq from my home directory listing. So I'm going to say p3 patrickbrc. Or also, if you run into mysterious errors, make sure you got your name at BV-BRC or name at patrickbrc.org typed correctly. I very often will drop one of the letters out of patrickbrc.org still, and sort of you'll get mysterious errors as a result. xx.fastq. Okay, so I'm doing p3less in this path name to the file in my home workspace. What this has done now, it's downloaded the file and sent the file into this pager program that lets me, I can up and down arrow through the data. I can use this to search. I can search for a string and it'll highlight it. On Windows, there's a program called More that'll use that. That one, I think you can only go forward through the file, but if you hit the space bar, it'll page you through the file. It's just let you get a quick look at the file to see what's there.
Was that a read file?
Well, let's see. Let's do it. The P3LS.
If we didn't show them what a read file looks like.
Oh, yeah. Let's take a look at what this file was. So this is a reads file. The structure of read files, if you haven't looked at them before, this @ line is an identifier. Then we've got a line that's your actual read data. We've got a plus. Then we've got this other line is the same length as your read data, but this is an encoding of the read quality for that read. So the data in a FASTQ file are these sets of 4 lines that for a correct file, the size of the read data has to be the same as the size of the quality line. And that's actually a problem we ran into with someone yesterday, that the assembly crashed and there was error in the output that said, oh, there's a line in the input data that the read size didn't match the quality line size. So alongside P3 less, if I've got a piece of data that I want to run through a pipeline, say I've saved one of these tab delimited files into my workspace and I want to dump it out and start another pipeline with it, there's a program called P3 cat. Cat is short for catenate, which means just dump the file out. Let's say I want to know how many lines are in this FASTQ file. There's a program called WC on Linux and Mac. I don't think there's a WC on Windows. Instead of doing P3 less, I'm going to do P3 cat on my FASTQ file. And I'm going to pipe it to WC word count. And it's taken a little while because this was I think this was like a 3 gigabyte file. You notice that when I did P3 less, it came up right away, because the way that works is it starts up the pager program and then it'll let you start looking at the top of the file while the rest of the file is still downloading to your computer. So I ran P3 cat to WC. And the output of this program is the number of lines, number of words, number of characters. So this is 3.5 million lines. So it's another bridge between the workspace and your computer. This was just a trivial example to show how you can run a command pulling input from the. Although this is something that if I'm looking at a file, I'll see the file size, right? If I look at it in the workspace.
So for those that are interested in doing more Linux-like stuff on Windows, you can install, I think it's just called WSL.
Yep.
Windows subsystem for Linux, and puts Linux right on your computer, so you can use the command line, and that is helpful if you want to learn some Mac style things, and you might be able to install the P3 CLI.
Yeah, that worked. Yeah, it installs fine there.
Easier. You can Google it, WSL.
That's actually very slick. It installs a full Ubuntu Linux build on your computer, and you can sort of install arbitrary software and compile up your bioinformatics tools or just install bioinformatics tools because they're available online for Ubuntu. And I think just about everything is there.
You could do things like apt-get install in CBI Blast right on your computer, or
SAM tools.
Yeah, SAM tools.
The question is, how is it different than VirtualBox? It's actually similar to VirtualBox in the underlying technology. It doesn't require having to have the VirtualBox application and sort of boot up a whole virtual machine. It's sort of a lightweight approach from the usability point. The way it works for usability is you just go to the start menu and click Ubuntu, and it gives you an Ubuntu Linux window.
Yeah, I guess the main difference is that you have Microsoft providing your virtualization layer and the integration with the hardware rather than Oracle.
It's also integrated well with the file system.
And if you're on the edge of doing some more bioinformatics types things, like there's guides for doing integration between WSL and say VS Code, which is an environment for programming. It's an IDE. So you can get a pretty nice setup for writing code, if you're trying to understand how to learn to write code. As a bioinformatics resource center, I feel obligated to enable you guys further to not just leave it in our hands to do programming.
Yeah.
It's also how you.
And in all honesty, modern laptops are, high-end laptops are pretty powerful machines, and you can do some non-trivial analysis right on your own laptop with this.
So you guys would recommend WSL rather than VirtualBox?
If you want to do Linux stuff on your Windows machines, yeah, it's just an easier integration.
It'll take up less space, I think.
What's nice is that if you're running the VirtualBox, what you get is a window with your Linux machine in it, unless you fiddle with things. You're running Linux and it's running the Linux window manager, and you've got its own windowing. So with WSL, you just say, give me a Linux window, and you've got it.
in VirtualBox, we have to allocate some space.
Yep.
So in WSL, we don't need to do anything like
Yeah,
that.
WSL is just an app. Just another, to Windows, it's just like another app, so you don't have to set aside some portion of your hard drive. It has access to your hard drive.
The question was disk allocation in VirtualBox. In WSL, it just uses a system disk, so you don't have to worry about that. I actually got Windows in a VirtualBox Windows on my Mac, but you can't install WSL inside a virtual Windows machine on a Mac because it wants to use virtualization stuff that VirtualBox isn't providing. You know, it's definitely something to play with. I mean, it's easy to install. It'll take a while because it has to download stuff from the network to pull the distribution down. But this web page here, that'll tell you how to do it. Yeah, the question is, at what point could you run out of the ability to use Windows for this? The WC was sort of a distracting example because it's not there on Windows. But the LS and DIR are that, that's sort of just a difference in the underlying commands. But all of the core functionality will work fine. To make a directory is mkdir. That should have worked. That's the same command on Windows and Linux. So we've listed the data. We've looked at it in a pager or dumped it into another program, but what we really want to do is copy the data back and forth. And so for this, we have a command called p3cp, CP for copy. And again, this is another difference between Windows and Linux, that the copy command in Linux is CP and in Windows it's copy. And they sort of act differently. So the way the copy command works is you give it a source and a destination path. This is why we've been talking about paths so much. So we want to be able to distinguish the path names that are on my computer and the path names that are in the workspace. And the way we do that is we put a WS colon in front of paths that are in the workspace, in the places where we need to distinguish them. If we want to download data from the BV-BRC workspace to my computer, I'm going to say P3 copy. I'm going to give it a workspace path that has this WS colon in front of it and my local file name on my computer. If I want to copy data from my computer up to BV-BRC, I'm going to say P3 copy, and the source here is now my local machine, and the destination is a workspace path. If we've got a whole folder of things I want to copy, I'll use P3 copy -R for recursive. And you can set the file types of uploaded files based on the suffix of the file. So if I wanted to say I'm uploading a .fa file and I want that FA file to be contigs, I use the map suffix parameter and say I want the suffix of FA to be type contigs. So we'll go through these in some more detail here. I've got a file of FASTA data that I want to upload to BV-BRC. See, since I am not on my computer, I'm going to make up some data. I've got some highly complex FASTA data here that I want to upload into BV-BRC. I'm going to use P3 copy. I'm going to give the name of my local file. And I need to figure out where I'm going to put it. So let's go back over here into my workspace and find a place I'm going to put the data. So let's see, I'm going to go make a new folder for this workshop. We went through making folders earlier in the workshop. Notice I made it with a space here, so we're going to have to be careful about spaces. So I'm going to go find that folder I just created because I want to copy the path, workshop UVA. So here's the path name to my folder. I'm going to copy that. Remember, I've got a file called data.fa that I want to put in to my workspace. So I'm going to say P3 copy data.fa. Now, because I'm copying to the workspace, I'm going to say WS colon. And now I just remember that, this file name has spaces in it. So I'm going to put this guy in double quotes. And if you are concerned about trying to remember whether or not you should use double quotes, if you want, you can always put these names in double quotes. It doesn't matter if it has spaces or not, whatever, you can just put it in double quotes and not have to think about it. So I've got WS colon. I'm going to paste in my path name, and I want to call this upload1.fa. So again, I'm copying. My source is data.fa in my current folder here. My destination is a file called upload1.fa in my workshop UVA folder. So it copied it to that file name with type reads. And I'm like, well, that's not what I wanted. I said this was a FASTA file of contigs. We'll fix that in a sec. But I want to go back to the workspace here and verify that it actually did it. So I'm up here in the workspace. I'm going to click on my workshop UVA. Lo and behold, here's my uploaded file in the workspace. It's got type reads, which is wrong. So let's fix that. I'm going to go back here. Remember, I mentioned in passing, there's this thing called map suffix. So what I want to tell it is that all of the .fa files that I'm uploading, I want those to be of type context. So I'm going to say FA because it's a suffix without the dot. I want to say upload with the suffix FA mapped to the type context. Copy. I'm going to use the same path name here. And it says, oh, there's already something there. I'm not going to overwrite it. It tries to keep you from smashing your data that's there. So the couple things we could do. I could say, oh, I really didn't want to do that. I want to have a new file there. So I'm going to change my file name that I'm going to upload to.fa. So now it says we did the copy into upload to FA. Now it's type context. So let's go double check that. Refresh this page here. I've got upload 1, upload 2. We've got our little icon has changed. And if I click over here, I see it's got type context. So exactly what I was looking for. So say that I really did mean to, because I had just messed up the command. So I want to clean this up a little bit. So I want to get rid of that file that was bad. So there's a command called p3rm for remove. I'm going to remove this upload to. And this is one of the ugly bits of the thing that p3 remove doesn't know about the ws: thing because p3 remove only operates on workspace files. And this has come up as an issue in the workshops in the past. That's one of the things that's on the list to clean up. So I'm just going to say p3 remove and that path name without the ws in front of it. Go back here and refresh the page. And my upload 2 is gone. So what I was getting to, I could just remove the upload 1 and re-upload it. Or I could go back here and arrowing up through my history here. I'm going to add another parameter to my copy command called overwrite. And that says, I don't care if there's a file already there with that name, just smash it and put the new file in place with the correct type here. I go back over here, I reload, and now I've got my upload FA and it's of type context now. So I've got my data in place that I was trying to get to. If I want to download the data, I'm going in the other direction, we'll do much the same thing. So say we've got that file of FASTQ data that we were talking about, and I want to bring that down to my computer so I can load it up in an editor and sort of fix the broken reads. I've still got that path up here. I'm going to copy the path to my FASTQ file. I'm going to p3 copy. Now the source is the workspace side. So the first parameter here is going to be ws: in my file. And I double checked. I don't have any spaces in there, so I don't have to worry about double quotes. Now I want to have it with the same name as it was on the other side. I can say dot. What is dot? Well, dot always is the name of the folder you're currently in. So if I copy something to dot, it's going to bring it down and it's going to give it the same file name that it had up on the workspace side. So now it's telling it it's copying my workspace path to ./xxfactq, which is the name I had up there. And I remember from before, it took a little bit for it to copy because it's a fairly large file. There we go. So we got our FASTQ file here. Now say we're going through Andrew's recommendation that we're just going to go fix this. So I can bring up my favorite editor. Because I'm a Unix guy, I'll use one called VI, which is a command line started editor. There's other editors that are graphical GUI-based editors. There's one called Sublime Text. If I want to do GUI editing of stuff and do it on files, that's not going to mess with things. If you're bringing it up in Word, it'll wreak havoc with your data, probably. Sublime Text works really nice for doing editing of this kind of data. And there's versions for Mac, and I think it has Linux as well. But Mac and Windows that work exactly the same. So if you're switching back and forth between Mac and Windows at all, if you use Sublime Text, you learn that editor, and then it works the same way for both of them. It's nice for editing text like this. But because I don't have that installed on here, probably I'm just going to bring it up in the editor. So now I got my data here. Let's say that first read was bad. I just want to delete this first read. So I'm going to go and delete the first 4 lines of the file. I'm going to save it back out. So now if I do an ls-l, I can see that my file is updated. It's a little bit shorter. I want to run it back through the assembler. And I want to just copy this guy back. Now we're doing the upload direction. So I'm going to start with my xxfastq. And I'm going to put it in the workspace. I think I pulled it out of my home folder. I'm going to put it back in my home folder. I'm going to call it xx edited fastq. So now we're going the other direction. And now I've got a file in the workspace that I could go to the services page and run the assembly on it.
So will that job you just launched show up in your jobs list?
I haven't run a job yet. I've just copied it back to my workspace. So if I go into my workspace here, this was in my home, I scroll down bottom here. Now I've got an XX edited file that I just uploaded. So here's the original, here's the edited one. Back to the job submission, which is the whole point of all of this diversion. So I'm going to go talk about job submission now. Remember that when we're filling out these job submission windows, you can think of it as two sets of parameters. There's some that are the same in all of these jobs, which is just the output name and the output folder. Now, we've done a lot of stuff with folders and file names, and so that should be pretty familiar. There's some parameters that are unique to each service, like we're looking at the genome annotation here. And so the annotation takes contigs and a recipe and a taxonomy name. There's some of these parameters that are quite similar across different services. There are a number of services that take reads. And so if you learn how to do the reads once, you can reuse that knowledge. All the submission scripts start out with P3 submit. And so if you remembering what we learned about command line completion, so if I say P3 submit, it's again on your Mac or your Linux. If I do the tabs completion, I'll get a list of all of the submission programs that are available. They all have detailed help messages, which can be quite long because some of these guys have a lot of options. Some of the submission dialogues are pretty complex too, and we've got to have command line parameters that map to all the things that you could possibly fill out in the dialogue. So this is again where submitting one job via the command line might be tedious, but doing 1,000 this is a lot easier than clicking through all of those. Each command has a pair of required parameters because all of these services have an output folder and an output name. And these show up as the last two parameters that you put on the command. So you do P3 submit whatever, bunch of parameters that define the job specific stuff, then an output path and an output name. We'll work through submitting a genome annotation. So remember that for the GUI, we needed to fill in the config file and the recipe and a taxonomy name. So each of these guys has its corresponding command line parameter. I won't read through all of this, but you can give a GenBank file or a contigs file. The command line will let you submit GenBank files. We haven't still gotten around to adding that to the GUI. So if you have data that's in a GenBank file, you can submit it directly using the command line. When we do the submission, these file parameters expect a path name to a file. And just like when we did the P3 copy, these files can be either local files on your computer or they can be workspace files with path names that start with WS. If you give it a local file, it will automatically do that upload for you. It'll sort of internally, it'll do a P3 copy to the place you want it to have. Where will it put it? By default, it'll put it in the same folder that you specified as the output folder for the job. If you want a different location, there's a parameter called workspace upload path that will let you put the data in a different directory. Remember, in the GUI, we specified either a taxonomy name or a taxonomy ID. And if you put one in, it filled out the other one. The GUI was helping us out there. Here, we have to do a little bit more work because you have to do it yourself. If you give it a valid taxonomy ID, it'll figure out the genetic code and the domain, Bacteriarchaea, on its own. So the full command then, submit genome annotation with a contigs file and a taxonomy ID and a scientific name and a location. Because I didn't set this computer up with the data, I know I've got some data here. I'm going to go find and copy it down. Here we go. I just so happen to have a Buchnera in my home folder. Grab this. So I'm copying this Buchnera FASTA file to my machine here. If I look at it, I see it's a contigs file. I'm going to do a submit genome annotation. Go back here. I'm going to give it the location of my contigs file. I'm going to give it taxonomy. You see here, I'm lumping all of these together into one line because I'm typing it and not copying and paste it. So on a Windows machine, this is what you'd have to do. And I'm realizing I didn't give you guys an easy form of test data to follow along, but I know some of you already have data that you want to run. So we can work through that later. I'm going to give it a scientific name. And here, remember that in the submission dialog, we have taxonomy name and label. What this does is that if you've run the annotations, you'll have seen this, but underlying submission, what it'll do is you'll take the taxonomy name, it'll tack your label at the end of it and call that the genome name for this genome. So that's what we're going to do here. I'm going to say my scientific name is Buchnera cola. I'm going to call this UVA. So that's all the parameters I need. Now I need to give it an output path. So I got my scientific name. Now I need my output folder. So I'm going to put this in my folder. And here you don't need the WS because it's only ever a workspace folder. I believe I call this workshop UVA. And I'm going to give it a output path of Buchnera 1. So do we see that this has uploaded my data and it uploaded it into my workshop UVA folder and submitted annotation with this job ID. So let's go look over here. Lo and behold, I've got a job running 9407056. There it is. So I've submitted my job and it's in the queue. One of the things we want to be able to do is look at the status of the job from the command line as well. Say I'm writing a script that's automating the assembly of 1,000 genomes, and I want to have a job that automatically pulls my data down when they're done. I can use the P3 job status program to see where my job is at. Say P3 job status, and I give it this job ID here. It tells me that's in progress. Okay, all good. If I want to find out some information about this job, it's like, oh man, where did I send the output? What exactly did I do? I can say P3 job status -V for verbose. And what this will do is it will spit out some additional information. It says it's running on this host. So if I've got a host here, that means it's actually in the cluster and running. I don't have a result code yet because it's still running. And I get this chunk of data here. What this is the parameters file that was created to run this job. So this is basically the complete description of the inputs to this job. And it's basically a set of key value data. You can see that the user ID that submitted it was mine. The parameters that went into the execution were, this is specific for the genome annotation. I've got a genetic code of 11, domain of bacteria. So this is where the system picked these for me because I gave it a taxonomy ID of 9. And here's my scientific name I gave it. Here's the path to the contigs. That path is where it got copied to in the BV-BRC workspace. Here's my output path. There's some internal details about what the scheduler decided that, it needed this much storage and this much memory to run. And here's my output file. So this gives you all the information there is to know about the job. If you're a programmer or you got a programmer, you want to sort of build out something on top of the scheduler, you can use this to sort of pull the information about that job. Let's see, but that's still running. So that's annotation. Assembly is the other one that people always want to run lots of. It's the same story, but it's here that we need to define the reads to be run because there's a lot of different options for reads. Remember the assembly GUI. We've got all of this mechanism here for choosing a paired end library, add it to our list of libraries, choose single end. We've got to mimic all of this at the command line. The way we do that is with a set of parameters. So here you can define a paired end library that's got the two files, interleaved if you've got interleaved data, single end libraries, or SRA IDs. And you can choose the assembly recipe, which defaults to auto, which we recommend, or you can explicitly choose, unicycler or canoe or spades or whatnot. Just like in the annotation case with the contigs, all of these paths can either be local paths on your computer, in which case it'll get uploaded, or you can give it a workspace path. One thing I'll note is that if you're submitting a job that's got a whole bunch of these paths in it, because the workspace paths are quite long, it can get really unwieldy. There's a shortcut that you can say workspace path prefix and give it a name of a folder. And then anytime you reference a path in the command, for instance, where I'm giving it paired end libraries, I can just say WS : and then just a file name without any path on it. It will interpret those as to be inside this path prefix folder that you gave it. And I'm checking job status, and we showed this, looking at the parameters, getting your results. Let's see if my job is finished here yet. That's still going, so let's go find another job to look at. I'll check the status on that one. Okay, that one's completed. I don't remember where I wrote the output for this one, so I'm going to do a job status -V in that, and I'm going to dump that out. Grab this output path. I'm going to do a P3LS on it. So I see when I did that, I've got two files in here. that have this out.2022.08. If I go back here in my parameters, I'm going to search for my output file. That's the output file that I gave for this job. But why are there two of these things here? Well, if I look at, let's do a ls-l on these. I see that this first guy with a dot in front of it is a folder, and the other one is a file. Let's just take a look at this file here. I'll use p3cat for that. The QA stuff is set up a little weird that the output folder has the name.json because that was the name of the input for it. So I'm going to use that. So this is another big JSON formatted file. So when you run a job, there's a bunch of metadata about the job that gets generated and put into your output path. This is actually what the workspace uses to render the output of the job. So we don't really care about that. What we do care about is this folder that started with dot. So I'm going to do a p3ls on that. So now we've got something that's a little more interesting. Now, remember I told you this was a monkeypox job, so we ran a program called Vigor. So these are all the outputs from that job. Say I wanted to get the GFF files from my viral annotation run. I'm going to copy this guy. I'm doing WS to, because it's a workspace file and it's called figure out.gff3. I just want to copy it in my current directory. So I'm going to say dot. It did the copy. And there I have the output of my annotation downloaded onto my local computer. I know that that last bit was a whole lot in not a lot of time. Just briefly recap what we did was looked at two of our submission jobs. We looked at sort of the bare minimum of parameters needed to run the job. We took advantage of defaults that the services have for us. We sort of figured some things out by looking at the submission interface in the website to help us find it. We used the website to help find the path names that we're looking at. We did the job submission. We got a job ID back. We verified that we could look at that job in the website and that we can look at the status on the command line. Waited for the job to finish, looked at the output of the job, and pulled the data back. A question that a lot of people have is that you keep talking about having 1,000 assembly jobs. What do we do with that? Right now, we don't have any pre-built tools that do this because the actual details of what you want to do may well be specific to what you need, right? You can see what has to be done. You need to say, well, I've got a directory with 1,000 FASTQ files in it. I need to somehow construct a command that has the right set of read library parameters to say whether it's single end or paired end read. I need to decide in my layout of the workspace, where am I going to put the output of these? What am I going to name them? All of these sort of things. To this point, this is something that people put scripts together on their own to handle. We keep talking about putting together some basic batch things, making some assumptions for you about how to do it. Maybe that can be a goal for the next workshop that we'll try and bring some of that out. But again, if you have questions about it, feel free to ask. We've done a number of these things for our own work because Jim has run tens of thousands of assemblies and annotations using the command line.
People that don't use the command line very much, in addition to being able to write scripts for batch processing, why else would somebody maybe want to use the command line?
Yeah, so the question is, apart from doing large batches, why would you want to use the command line? One of them is that if your data that you want to process is all sitting on a server somewhere, you're not going to probably run the web browser on that server. So if you can get the command line tools installed on that server that's got all the data on it, you could run the submissions from there where the data is sitting without copying it to your laptop and then copying it back out.
And also through scripts or something, if you had something that's going to take a lot of time, you potentially queue up a script or have something that just
right.
It runs and it does its thing.
Yep. Yeah. If you've got, again, your 1,000 FASTQ file, your tens of gigabytes of data that you load, you don't want to, have to leave your computer on and running and doing those uploads and worrying that they'll crash. You can do the submission right from where the data is.
But there's mostly one-to-one correspondence between the functions delivered through the CLI and what you can do through the website with a few exceptions.
Yeah, we've tried to expose everything. The annotation and assembly submission scripts are the most exercised of them. The other ones are less used, so we may run into glitches.
We don't necessarily have a set of commands for all the services, do we?
We do we try to cover the space. Yeah, it looks like primer 3 isn't there, but we've got taxonomic classification, variation, RNA-seq. RNA-seq is another one of these complex ones. Yeah, there's, reference for doing the conditions and contrasts and, yeah, so this, because that's a complex submission, that the command line for it will be complex. But yeah, we tried to cover the space. We got some more recently added services that we'll need to add submissions for.